All right, bet. We finna get into another quadratic inequality. The first one we did was a quadratic function that was greater than 0 or positive. Now, we like to get into all different type of examples because anything can end up on the exam. So I'm gonna switch it up right now and do something that is less than 0 or negative. Here we got x squared minus x minus 6 is less than 0 or negative. So we're gonna do the same format. Look at that middle term. We're gonna change the middle term into two terms so that we can get a good clean factor, right? So here the middle term is negative x, right? So we're gonna switch that negative x into positive 2x minus 3x, because you know that plus 2x minus 3x is the same as minus x, which of course means that we still got the same function, it's just in another form, right? And that's what we want. We want everything to be equal. So now we're gonna do our little partition, right? So we can see the two factors that we're gonna make. And on the left side, we got x squared plus 2x. The greatest common factor is x. So we're gonna take that x out of the x squared. Of course, that leaves x. Multiply it back just to check. You still get x squared. X times x is x squared. Take the x out of 2x, and that leaves just 2. X times 2 gives you 2x. So we got the same function. Now let's do the other side. Greatest common factor is 3, or negative 3. So we take that 3 out of 3x, and that leaves just x. Negative 3 times x gives me negative 3x. Then we take that negative 3 out of this negative 6, which leaves positive 2. Now we got the same function, just in a different form. Now we're gonna do the next factor, because x plus 2 is now the greatest common factor in this new form of the function. We're gonna take out the x plus 2. So we take the x plus 2 out of the first term, that leaves just x. And that x plus 2 times x gives us back what we already have. It's the same thing. Then you take the x plus 2 out of the next term, which leaves negative 3, multiply it back, and we get the same term. Now we got our quadratic function in the factored form. So now we can collect our zeros for the function. All right, so given this factored form, we can see that either the function could be made 0 if x plus 2 equals 0, or if x minus 3 equals 0. Then we do the same thing, solve for x for both zeros. So subtract 2 on both sides and add 3 on both sides for the x minus 3. And they all cancel out, and we get one 0 is gonna be x is equal to negative 2, and the other 0 of the function is gonna be x is equal to positive 3. All right, you know what we're about to get into, right? The infinity table. So we write our negative infinity on one side, positive infinity on the other side, draw our vertical lines coming down from them, then draw the horizontal line across so that we begin to make that table. Then we count the rows. There's 2 factors plus the row for the product combination. So we got 3 rows all together. Then the next part comes to the aesthetic part for me. I write that real number line in the top left corner, and then I write my arrows on the lines to indicate that we are dealing with the real number line. Again, it's aesthetic. For me, it's just like in my head, I'm activating the table, if that makes any sense. It's kind of like the table is a machine and I'm turning it on. So here we're at the point where we put the zeros in from least to greatest. Negative 2 is least and 3 is greatest. So now we got our table looking like a table, and we can incorporate the factors in each of the rows and the product combination on the bottom row. All right, next step, we're gonna go on the real number line and put our dots where they need to be with their zeros. X plus 2 is negative 2, and x minus 3 is the positive 3. And put our negative signs to the left and our positive signs to the right. Now we can do our product combination. Negative times negative is positive, positive times negative is negative, and positive times positive is positive. Now, what do we want? Negative, less than 0. That's what we care about. We don't care about the positives, x, x. Check for the negative, because that's what we want. So that's the only interval that we're paying attention to. And when you look at the top of the table from the checkbox, you can see that that interval is -2 to +3. Boom, we got our set of x values that satisfy the quadratic inequality. So at this point, technically we're done. We are done. We got our answer. However, again, your teacher or professor might want it written in a different version with the inequality signs in it, as opposed to the set version of it. So our set is the same as saying -2 is less than x and x is less than 3. And that's our other way of writing our solution. All right, if you got any questions, concerns, drop a comment. If you got any recommendations of what type of problems you want to see solved, drop a comment, like, subscribe. Peace.